Here we are, and welcome to my no-nonsense approach to going through the OCR paper from the summer of 2024. It's the foundation tier, it's the old J560 spec, and so, as with OCR, weirdly, against all the other exam boards, paper 2 means non-calc. And as you can see, that's why. Part A, whether you do it mentally and think of it as money, £6.30 plus £4.70, or if you want to keep it nice and safe, stick to column addition, and obviously therefore for B, stick to column subtraction. If you want to play it safe, or if you want to do it mentally, it is only 1 mark per question, so it is for the answer. But no point in risking it. However you do it, make sure it's 11 or 11.0 for part A and £4.23. Probably B's a bit easy to do mentally for me because I just take away 20 pence, take away 7 pence, and there we go. But again, if you want to keep it safe, stick with column subtraction and addition. Number 2, we have some negative numbers. Do not fall into the trap of 2 minuses make a plus. They do not. That's an incomplete statement. They do when they are being multiplied. They do when they are being divided. Not in this situation. This situation means if the temperature starts at -7 degrees and goes down 4, you'll end up even further down at -11. B is where, if they were both negatives, yeah, I get it, but no. 42 divided by 6 is 7. The rule I use when you are multiplying and dividing, if the signs are different, and they are here, negative, positive, the outcome is negative. Here, this is where 2 minuses make a plus, because 2 minuses do make a positive when, so -4 times -4 gives you +16. Number 3, as always with these, I cheat because I don't trust myself to get it right live, so to speak. Mirror line, don't forget, however far the original is away, in this case it's 2 squares away, should be 2 squares on the other side, 1 and 1, 3 and 3, and that's how you build it up towards a posh dot to dot. Question B, rotating it anti-clockwise. You are more than welcome in an exam to ask for tracing paper. If you want to use tracing paper, make sure you know how to use it. It's amazing how many students I've taught forget to shade in on the reverse side and it just doesn't work out. But I don't use tracing paper, I do it by counting. I look at that vertex and think, right 1, up 1 will become up 1, left 1. That's my idea. This one is right 2, down 2. That'll become right 2, up 2. And once you've got 2 vertices in the right place, you're probably okay to go ahead and fill the rest of the shape in. Number 4, just that bit of knowledge that if you know the radius, you double it to get the diameter. 3 times 2 gives us the 6. On to number 5, probability scale. Always make a note mentally of where they are. You can, if you wanted to, put some fractions on already. There's a total of 8 here, so it's all in 8s. Write down as a fraction the probability of picking a blue counter. That's that one. If they're all in 8s, that's 1/8. On the probability, mark not picking a blue. 1 minus. The probability of something not happening is 1 minus the probability of it happening. Or another way of thinking about it is 1, the numerator on the not happening, the numerators need to add up to the denominator. Okay, 1/8 plus 7/8 adds up to 1. total of all outcomes. Number 6, a bathroom shower. Again, loads of waffle, loads of yada, yada, yada. It's wanting you to do 15 per minute for 12 minutes. Means however you do it. You can do it as short or long. You can do it as halving, doubling, whatever method you prefer to do it, as long as you get 180, then it's worked. For number 7, we are turning 0.6. Go back to primary school, think about your place value. Hundreds, tens, units. After the units, after the decimal point, we get tenths. So the 6 is in the 6/10ths, needs cancelling. They're both even, get them halved. Part B, write as a mixed number. How many times does 5 go into 17? It's 3 with a remainder of 2. But you keep the bottoms, the denominators don't change. Number 8, inequalities, but a bit of knowledge of your units as well. Look on your ruler for the top one. You'll notice there are 10 little notches, so 6 centimetres is indeed the same as 60 millimetres. For this one, convert your kilograms, it's times by 1,000. So as you can see, they are definitely not the same. 3.2 is definitely the bigger of the two, so 320 is less than. And for this one, similar thing, I would divide it by 1,000, so it's actually becoming 17.5 kilometres. So try, if it went again, if you divided it again, it would be 1.75, and that would lead you down the equals route, but it is not. So the numbers are the same, but the place values aren't. 17.5 kilometres, again, gets the open end. Hopefully you didn't fall into the age-old trap of, oh, there must be one of each, so I'll just put the great. No, that's not always the case, and number 8 here proves it. Part A, for number 9, several ways of doing it, but the easiest, the quickest, leave the 16ths alone, turn the quarters into 16ths by timesing it by 4, but whatever you do to the bottom, you do to the top. The reason it's asking for simplest form is some people might have gone for a number higher than 16. They might have done 16 times 4 to get 64. That's quite a common method, but we've gone for the LCM of 16 and 4 hours. There is no number that goes into 3 and 16 that will cancel that down. On to B. How do we divide? We don't. I'm sure some of your teachers have said KFC to you before. Keep. Flip the second fraction. Change the divide to a times. You're more than welcome to do top times top and bottom times bottom and cancel that down. You will get 3/4 as your final answer, which is correct. But don't forget, you can pre-cancel. Divide the top by 5 and the bottom by 5. Divide the top by 3 and the bottom by 3. As long as it's top and bottom. But now look what you get. 1 times 3 on the top, 4 times 1 on the bottom. By pre-cancelling, cancelling before you multiply, you get to the final answer a lot quicker, and you avoid the possibility, because 45 over 60, I'd argue, is relatively friendly. What happens if the numbers ended up in 3 digits, and so on? Not so friendly. Number 10, we're simplifying. We are collecting like terms. What are your x's? You've got 6 of them, positive. You've got 5 of them, positive. That's 11 in total. Y's, we start with 3 of them, but we take away 1 of them. We're left with positive 2 of them. Part B, when you are multiplying numbers and letters, do the numbers first. 5 times 6. And if it was something like A times A, it'd be A squared. It's not. You can't do A times B. There's no way of simplifying that. That's it. Just leave it as AB. Number 11. According to the mark scheme, spelling's not a problem as long as it looks like what it should. Plan view, don't forget, is the view from above. If you see a shape from above that is a rectangle, from the front is a rectangle. There's only one thing it can be. That's a cuboid. If you don't know what a cone looks like from above, a cone is basically a pyramid with a circular base. So when you look at a cone from above, you'd see the apex, the vertex there, and you'd see the circular base, but that's all you'd see. And from any elevation, the side or the front, you'd view it as a triangle. And the third one, you don't need, the mark scheme does not need the word triangular. You can put it in, and it's great if you did. But the word they're looking for is that it's a prism. If you extended it into 3 dimensions, it's a wedge shape. All right, but the best name, the perfect name for it is a triangular prism, but triangle is accepted in the mark scheme. Number 12, laws of indices. When your base numbers are multiplied, you add the powers. We do 3 plus 4. I squeeze in a 7. When you have a power to a power, that's the occasion where you multiply the powers. 2 times 4 makes 8. Number 13, if you haven't spotted those numbers before, they are your triangular numbers. Because there's a 1, fits in a triangle. There's a 3. If you play pool or snooker, you'll know where it ends up. It ends up in a game of snooker with 15 reds. Part B, we have Fibonacci. The right-hand side one is the easiest because you add the 2 numbers before it to get the next number. Now, if you follow that logic backwards, you need to do 10 minus 7 to get 3, because it would be 3 plus 7 to give you the 10. Number 14, equations of motion. They sound a lot more complicated than they are. The bit of revision you need to put in, if you don't know it, is that initial velocity is the letter U. Acceleration's a bit more obvious, that it's A. Distance, well, there's no D in it. Distance is an S. And V is the final velocity. My U looks a bit like a V there. Let's get it properly curved, just to exaggerate it a bit. So this boils down to substitution and following bid mass. We're trying to find the final velocity. We need to work out, according to bid mass, U squared, indices, powers come first. U squared is 6 squared, 36. Added, and again, glance at bid mass, multiplication comes next. That's 2 times A times S. 2 times 4 is 8, times 8 is 64. Simplify, you now know that the final velocity squared is 100, so the final velocity, you need to square root it. It's 10. So we are obviously getting into the more trickier questions now. We're into that different phase of the paper. Number 15, good old waffly questions. Like I've mentioned on the last video for paper 1, Just because on the cover it says you should read through questions clearly before answering, I couldn't disagree more. One line at a time. Can you do any maths? If not, make a highlight or circle a number. So, top line, compost is used to grow plants. We knew that. Ivan has a sack containing 50 litres. There's no maths we can do to that. We look at the answer. The answer is also in litres, so there's no need to change it to millilitres or anything. He uses this compost to fill pots, don't care. So we've been told very little from the top. Ivan fills 6 large pots, each holding, stop, 6 pots, each with 7.5. Get multiplying. Keep the decimal point in, or some of you I know will put it in at the end. I just like to do as we go along here, because it's just normal short multiplication. 6 times 5 is 30. 7 times 6 is 42. Add on the 3. So Ivan's 6 large pots are holding a total of 45 litres. He had 50. It's now easy. He's got 5 left in the sack. He uses the remaining compost, that's that, to fill small pots. We're now into millilitres. So he had 5 litres left over. That's 5,000 millilitres. Work out the maximum number of small pots. So you've got a couple of techniques. If you're not confident with your dividing, just write out your 400 times table, your 4 times table with a couple of noughts on, until eventually you will get up to 4,800. In other words, you'll get 12 small pots can be filled. If you went for a divide, it looks hard until you realise it cancels. So you're essentially needing to do 50 divided by 4. Well, if you do 50 divided by 2, you get 25. Divide it by 2 again, you get 12.5. What's the difference between those? Because the 0.5 is not a full pot. He'd have had 200 mils left. And that knowledge answers part C. He'd have used 4,800 of his 5,000. He's got 200 left. Number 16, extremely complicated. Very, very wordy, very waffly. But my advice is stick with it. Don't let it put you off. Because there's one key word after you've looked through all that waffle. Use estimation by rounding each value to the nearest whole number. So we can go back to all this rubbish info. 20, 30, 40, 4 1/4, no, 4. They're the nearest whole numbers. So we can move on. 1 week she works 40 hours and that'll be at normal pay. 4 2s are 8. Stick the 2 zeros on. She works 4 more hours for an extra £30 an hour. 4 3s are 12. Stick a nought on. Her total wages, 920. By rounding each value, show that she may be correct. Yep, you are correct. You will at least earn £900. There we go. Part B, give one reason why she can be certain. Well, look at all these numbers. £20.15 gets rounded down. The amount of money there gets rounded down. The number of hours gets rounded down. So every number we are dealing with is rounded down. You can Put that into the words if you want. Every number has been rounded down, which leads you to being of the knowledge that we do indeed have a big underestimate. She's probably nearer 950, maybe even 1,000. But don't try and work it out properly. It's only worth 1 mark. Don't over-waffle, over-complicate. Number 17. If you're doing a tricky dividing like that, times each number by 100. Because the answer is the same. 1.2 becomes 12 if you times it by 10, and it becomes 120 if you times it by a total of 100. The 0.03. So really, you're replacing a tricky question with a much simpler question. And there you go. That's all it is. 40. Number 8. Another waffly question. What's the big thing you're looking for? He finds the positive difference. Difference means subtract. So to fill it in, 9 take away 2, or because it's positive difference, you always needed to do biggest number, take away smallest. 9 take away 2, 9 take away 5. Fill these in. 5 take 2, 9 take 2, and 9 take 5. Find the probability that Kai takes 2 cards with a difference that is even or a factor of 10. Different pen just to illustrate. Even, get them circled. Don't be afraid of using your diagram. There's your even numbers. 5 is a factor of 10. The rest should all be either odd or numbers which do not go into 10. And there we go. Find the probability. In the grid, there are 12 numbers, 6 and 6. How many have we circled? 6. Feel free to simplify it. It doesn't ask you to. Number 19, good old constructions. So get your ruler and compasses out. Method, don't forget. Set your compasses so the distance between the legs, that's the metal one, and the one which will have the pencil in, this distance must be greater than halfway. So my compasses were set at that distance. Metal point on one end, I draw a semicircle. Pick it up. Metal point on the other end, I draw another semicircle. Although some people will lift their compasses off, that's fine. As long as they cross, that's all you want. Do not rub out your construction lines. Get your ruler, carefully join the 2 crosses, and do a quick eyesight check. Does it look like a right angle? Because it should, hence perpendicular. If you want to get a ruler and check that they're the same distance, feel free. I personally don't bother. I just do a quick sight check. Number 20, vectors can put people off, but they're not as bad. Write A as a column vector. A vector is a movement. Going from there, because that's the direction of travel, to there is right 2. Top number is 2. Down 3. Negative 3. Vectors are similar to coordinates, but they are instructions on movements, not positions. Part B, as you can see, is basically the same thing, but in the opposite direction. How do you change the direction of a vector in algebraic terms? You either know it or you don't. You stick a minus in front of it, because that would change left to right, right to left, and so on. On to number 21. Wordy waffle. Definitely one thing at a time. Ryan makes a journey of 200 miles, okay? 1/10 of. Stop right there. 1/10 means 20 miles. Bit of a recommendation here. No, you don't have to include your units, but if you've ever found yourself on a very wordy question, doing some calculations and going, I actually don't know what this number means, it's because you've got lost in the question. That's helped out by writing out your units as you go through. Anyway, he's travelling 20 miles and the speed limit, he's doing 40 miles per hour. So let's do a bit of common sense. If you're travelling at 40 miles per hour, 20 miles will be done in half an hour. You don't need your DST triangle to work that out. But obviously this you could have done. This is a DST question. Next line, 40% of. Stop. 10% is divide by 10. 40% multiplied by 4. So the third line is talking about 80 miles and he's travelling at 50 miles per hour. Now this is a bit harder, so let's refer to our DST triangle. We know our distance, we know our speed. We need to do distance divided by speed. You can knock the noughts off. 8/5 is 1 3/5. Now let's just stop a second, pause and think. We don't normally talk in fifths of an hour. We normally say quarter of an hour. Well, don't forget, a quarter of an hour means 60 divided by 4, 15 minutes. We say half an hour. 60 divided by 2 means 30 minutes. So how do we work out 1/5 of an hour? Do 60 divided by 5. So 60 divided by 5 means that a fifth of an hour is 12 minutes. So 3/5 of an hour is 36 minutes. That for me is the tricky bit of this question. The remainder of the journey takes him 1 hour 30, leaves home there. Doesn't break the speed limits. Find the earliest. So we're assuming he is indeed travelling as fast as possible without breaking the law. That means he starts at 8:50. We've got 30 minutes there, 1 hour 30 there. So we're definitely adding on 2 hours of his journey and another hour there. That's taken us up to 8, 9, 10, 11:50. Then we've got the other 36 minutes. I break it down. 10 minutes takes you up to 12 o'clock midday. So we should be looking at 12:26. Okay. No need to muck around with PM. It's in 24-hour clock mode. Write down any assumption. So anything referring to the fact that Ryan has been able to drive at a constant speed. There's been no stoppages, no road blockages, no rubbish like that. Anything that leans into the fact that he doesn't have to reduce his speed at any point, that he can basically travel the full distance at that speed. Number 22, scatter diagrams. Again, I always cheat because I don't trust myself to do these things live. Question A. Describe the type of correlation. As you can see, it's on an uphill trend. So we can make the statement, it's not asking for a statement connecting science to mathematics. It's just asking for the type of correlation. So you just need one word, and that one word is positive. I'll just get my pen sorted. That's all you needed. Question B. One pupil took a test, was ill, and had to leave early on the maths test, which means their science test is going to be following the general trend, but their maths test will be exceptionally low. It has to be that student there. This one up here, not the same student. That student scored incredibly high in maths, 53 or so. They're basically top of the class in maths and mid-table security in science. Part C, by drawing a line of best fit. Now, if you're one of those people who panics and spends ages with them, I've looked at the mark scheme. Hopefully you can see these purple lines here. They're called gates. Now, the idea is the examiners will have an overlay on their screen that they can lay over your work. And the key is, I've written on there where those gates are supposed to be. So as long as your line of best fit goes through each of those gates, if it misses one by either being too low, high, or too short, you will lose that mark, I'm afraid. So make them as long as you think possible. Always go beyond the edge of the data. And if you're not sure, go off the edge of the graph. No one cares. Estimate the score for a maths pupil who scored 28 in science by pure coincidence. Doing it on screen and on my original, I actually get 28 both times. The mark scheme doesn't have any leeway. The mark scheme simply says allow follow through from your line of best fit. In other words, they are going to check that you've drawn your line on and you've read your answer off correctly. Part D, explain why you wouldn't use a scatter diagram. Explain why it might be unreliable. So for 60, we don't have any data going beyond the 50. So any data, the phrase I would use is that it is outside the range. That's a very common question. All right, if you want to be posh, it's called poor extrapolation. But if you forget the correct phrase, just go. There is no data around pupils for scoring this. It's outside of the range of the data that's been given. In your own words, but I probably overcomplicated it there. Don't. Find the percentage of the 20 pupils who scored less than 30 in both. There's no lines to draw for this. You're simply going to be looking, I'll go to blue, I think. You're looking for all the students who are inside that box. 30 and 30, they need to be inside. That student's not. It's got to be below. That student's actually on the line, so don't include. It's those 3 and it's those 4. In other words, there are 7 of those students out of 20. Now you've got the problem of turning it into a percentage. Couple of ways of doing it. Change your fraction. So it's got a denominator of 100. So multiply top and bottom by 5. Or take your 7/20, multiply it by 100, and you attack it fractions wise. Take a naught off, you end up with top times top, bottom times bottom, and you can probably guess that 70 divided by 2 is another way of getting to 35. However you get there, no one cares. Number 23. I always look at these questions and say, are we doing a perimeter question or are we doing an area question? So I scan the question, I get my answer. An equilateral triangle will have all sides equal to 14. Add them all together, or just do 14 times 3, 42. That means the perimeter of the rectangle is also 42. We're going to simplify. The perimeter is A, that's 4 of them. And there's a couple of 5s. In other words, 10. And now you've set it up, you need to get it solved. Subtract 10 from both sides. What am I doing? I'm writing other stuff down. 32. And when you divide both sides by 4a equals 32, divide both sides by 4, and you get your answer of 8. On to Charlie. Charlie's investing. Now, you haven't got a calculator. If you did, you'd be going for multipliers. You haven't got a calc, so you've got to do it a little bit old school. Find 10% by dividing by 10. So 5% is half as much. At the end of year 1, he'll have 1,200 added to 60. That's his cash at the end of year 1. We now do year 2. 10%, take a 0 off, £126. 5%, halve it, £63. And there we go. We add on the 63 to his investment at the end of year 1. Bosh, we're getting 1,323, or you could have just added the 63 and the 60, because that's what you get. If you've gone for it my way, it's a show question. Best do a takeaway. However, which way you go about it, again, no one cares, as long as you've written down all your thoughts and ended up with 123 somehow. Number 25, what an incredible lot of waffle for 1 mark. Feel free to read it all. Personally, I wouldn't. Give a reason why Jane's claim may be unreliable. If you've got a machine making bolts, have a think, how many would you expect it to make in a day? You've seen those factories, they make hundreds, thousands, if not hundreds of thousands. Give a reason why Jane's claim may be unreliable. That's mine. She's only checked 10. Don't need to read all the rubbish. Oh, there we go. To prove I didn't read it, the machine makes 2,000 bolts a day. She's only sampled 10. At least sample 20, maybe even 50. 10 is too small. Whoops. Number 26, Venn diagrams. 50 people. The ratio of those that only have a car. Now, you could do it the algebra way. So it's car to bicycle is 2 to 1. In other words, whatever's in there must be doubled to get that. There are 50 people in total. There's 11 we already know about. So these 3 X's must be worth the other 39 people. Done. We know that X is 13. So bikes are 13. Cars, double it, 26. Because that's not the answer. Don't celebrate too soon. One of the 50 is chosen at random. Find the probability that they have a bike. There are 23 people that have a bike. There are 50 people in the survey. It's 23 out of 50. Doesn't cancel. Number 27. Quadratics. We're into the grade 5 stuff. Show. They're always the ones that put they're the ones that put students off. You're talking area of a rectangle. How do we find the area of a rectangle? We take the length, we multiply it by the width. That would give us the area. Let's expand the brackets. X squared minus 2x. Do loops or grid? They've given you plenty of room if you want to do it the grid way. It's entirely up to you. I do loops sort of mentally. X times x minus 2 times x, and so on. Plus 7x minus 14. It's asking us to show this. We need it equal to 0 on the right-hand side. We've got x squareds minus 2x plus 7x. Keeping one eye on the answer. Minus 14 minus 70. Yep, keeping one eye on the answer. Job done. Solve it by factorising. We need double brackets with x's at the beginning. We need to use this space to think of pairs of numbers which multiply together to make negative 84, but add together to make 5. Start making your list. All right, you haven't got a calculator? Tough. You start with 1s, 2s, 3 times this, and so on. And eventually you will realise 12 7s are 84, and they're 5 apart. Which one do we need? Because one's got to be a negative. The answer is there. Positive 12 multiplied by negative 7 does indeed give you negative 84. 12 added to negative 7 does indeed give you a credit of 5. You're done. But it is solving. You've factorised. How do we solve? Change the signs is the quick way. I'm sure your teachers have nagged you about. And finally, find the length of the longer side. We're not going to be using the minus 12 because minus 12 take away 2 is a minus. Minus 12 plus 7 is a minus. There is no such thing as a negative length. So we're only going to be using the number 7. X is 7. 7 minus 2 is 5. 7 plus 7 is 14. Because 14 fives, there's your area, 70. 7 plus 7 does mean the longer side is 14. Take a breath, applaud yourself, and we are done. So I hope that was no nonsense. Hope we got through it quicker than some of these websites out there are doing. And I might just see you on paper 3.